The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. This is Tad Radzinski. I'm going to be doing the webinar today. I want to welcome you to the webinar, How to Use LCA or Product Carbon Footprint Results to Drive Your Sustainable Product Innovation Process. So this is an extension of the webinar we did last week where we focused in on how to use LCA or Product Carbon Footprint Results to decarbonize your products and operations. So this is definitely an extension of that, and we're going to talk about some of the elements we learned last week and move this forward as we go through the webinar today. Before I do get started, though, I do want to get into some of the housekeeping activities. Just a few notes here. We will be taking questions, and you can ask your questions at any point during the webinar. Definitely typing them into the questions pane, which you can see here on your control panel on the webinar. You'll see the question pane, and you will have the ability to type those questions in at any time. I would encourage you to do it throughout the webinar. We will have some time at the end to answer those, and we will be compiling and answering at the end as much as we can. For those that we don't get to answer, we'll definitely be working on that in terms of responses to all of you as part of the resources that we provide. The other thing I want to talk about is engagement. Throughout the webinar, we're definitely going to be asking questions for all of you. You will all be muted during the duration of the webinar, so you have to put your questions right in the question box, like I said. I also want to let you know that this webinar software does not give us the ability to do a public chat. So that means you aren't able to chat with each other during the webinar. However, our team can see every question, comment, and answer that you put into the questions pane, and we will make sure to address it. So please put all comments, questions, etc., into the question pane, and we'll be able to support you in any way with that. So thank you for that. The other thing is, just like last week, we're making this very interactive. I'm excited about that. We want to definitely have people participating and having the ability to interact. There will be a series of polls we put out today that you can answer, and you can do that through the polls pane right in the dashboard. And when we ask the question, what you can do is answer the question and then click submit. We're going to give you some time to do the answers, and then we'll look at that as a group and we'll talk about it. The other thing is this webinar is being recorded, and we will be distributing it to all registrants within 24 hours, along with any support materials that we provide for this as well. So looking forward to getting started. And like I said, any questions, go right into the question pane or comments. So again, I'm Tad Radzinski, President of Sustainable Solutions Corporation. Really excited to do the second webinar in our series today, and really taking a deeper dive into looking at how we can interpret LCA results, looking at some market drivers for sustainable product innovation. If you remember last week when we did the webinar, we looked at what were the market drivers for life cycle assessment and product carbon footprints. We're also going to dive into what we define as sustainable product innovation. A really important aspect of taking the results of a life cycle assessment or an EPD or a product carbon footprint and using that information to make your products more sustainable. We're also going to be looking at how to incorporate SPI into your new product development process. We're going to get a little fun exercise that we get to do. I've been doing this for quite a few years. It's the Lego exercise. Ideally, if we were all live and in person, you'd be touching Legos and assembling them. But in this case, we're going to have you kind of select the Legos you would want as part of the exercise. And that will be done along with the poll to put your answers in. So that'll be coming up in about the middle of this presentation. And then we're going to talk about decarbonizing your operations and then driving continuous improvement. So a lot to cover today. I'm really excited about it. And just a reminder, we are really big into training and education. We've been doing that since the beginning of time with our company for the last 22 years. I've also been an adjunct professor teaching in the university setting since 1998, and I spent 18 years teaching at Villanova University. So today, we do have a lot of experience doing life cycle assessment. When we started doing life cycle assessment, it was in 2007. We've done our first EPDs in 2010 and 2011, And I would say we've done hundreds of LCAs and EPDs to date, and now a lot of product carbon footprints. That's a lot of that activity. And we started actually doing our sustainable product innovation activity in 2009. So that is something that we've evolved and developed over time. And I'm going to share with you the tools that we use for that and how we've evolved those to integrate these things into the different activities we do with the various companies we work with. So let's start off by interpreting LCA results. If you remember last week, we talked about what is life cycle assessment. It's definitely a method for identifying the environmental impacts of a product, process, or activity over its entire lifespan. If you remember, we talked about the different life cycle stages, and we always start with the extraction and processing of raw materials. So I use an example of paper. That would be the trees in the forest. We start out with those to make paper. We then transport those trees to a mill where they're made into paper. That's the manufacturing process. So these three steps here would be considered what we call cradle to gate, where the raw materials come in, they're transported, and they're manufactured into something. And then that paper would come out for our use. We would use that paper, and then at the end of life, that paper could either go to recycling or landfill or disposal, whatever we're going to do. So what we look at when we do life cycle assessment, we're looking at either just cradle to gate or cradle to grave, or ideally cradle to cradle if we can close the loop on products. And we'll talk more about that in a little bit here. The other thing I did talk about last week that I want to recalibrate everybody on is the different types of emissions when we're talking about greenhouse gas emissions. We do that in form of scopes, and scope 1, just a reminder, is basically all the fuels that we would burn. These are direct emissions from fuels that are burned in our buildings or our factories or in our company vehicles. And it's usually in the form of natural gas or gasoline or oil or things like that. And then scope 2 are the emissions that come from energy sources that we would purchase. So for example, the majority of all of us purchase electricity from an electric utility off the grid. And that electricity is, we're using it directly, and we're accounting for that use under scope 2 emissions. But the generation of that electricity is really someone else's, possibly scope 1, if they're burning natural gas to actually create those electrons that we're using. This could also apply to purchase steam or anything like that. So scope 2 would be the indirect emissions that we use the energy, but we're buying it from someone else. Here in scope 1, we're using the energy and we're burning it in our operations. And then scope 3 are the emissions that come from assets or activities that are not controlled or owned by a particular organization, but we have direct impact by using those things. So typically we're looking at scope 3 as the emissions that come from our suppliers. Scope 3 could be business travel or transportation or different things like that. And what we are looking at when we are trying to get scope 3 information is that scope 3 is usually someone else's scope 1 and scope 2 that we're trying to account for. And I will say that scope 3 typically in most industries is the largest source of emissions for most companies. So if a company is setting goals to reduce their carbon footprint, they can focus on their own scope 1 and scope 2. But if 75% or greater of their emissions are coming from their suppliers, that's a really big deal that they have to focus on. And the beauty of LCA, it allows us to look at all of these and understand those. So if you remember last week, we also looked at different LCA results that come out of running a life cycle assessment. On the right here, you can see all the different life cycle stages. Again, the raw material stage, the raw material transport stage, manufacturing, packaging, distribution, use, end of life. And these are impact categories. If you remember, we talked about this. We looked at the Tracy methodology last week. Global warming potential is the one we're going to be talking about quite a bit today. But there are other life cycle impacts that we look at when we run a full life cycle assessment. Remember, when we do a product carbon footprint, we're only looking at the global warming stage. So if I click on this and go to the next level here, and I really look at global warming potential, I want to point out here that in the raw material stage, the blue, those are typically from suppliers that I'm sourcing materials or raw materials or products or ingredients from, and that would be scope 3 emissions typically. And this is also an indication of when I'm running my LCA, it gives me an indication of where are my impacts coming from raw materials. And this is where sustainable product innovation really comes into play. What's happening in terms of the transportation piece, you can see that's kind of small, but that's still something I want to consider in my sustainable product innovation process. Is there a way I can reduce those emissions? And then in the manufacturing stage, this is what I control, the scope 1 and 2 in my manufacturing plant. So we're going to talk today about how you can reduce those emissions, which will in turn end up reducing the overall carbon footprint of your product, or what we call the embodied carbon. So when I mention the word embodied carbon today, I'm going to be talking primarily about the raw material stage, that transportation stage, and then the manufacturing stage. That's typically the embodied carbon or cradle to gate stage that we really focus in on, that we have the most control of. We also have the ability with using life cycle assessment to really understand the materials. So if I go back here, you saw the raw material stage was making up about 30% of the impact of the product. So I come here and I want to understand, well, what materials are driving that? Here you can see I have 10 different materials. I've run life cycle assessment. On the global warming potential side, I can see this material, the blue one, is really driving my impact. So if I click again and I start to look deeper, I know that material 7 is something I probably really want to zoom in on in my sustainable product innovation process. And then material 2 and material 1 are also fairly big impacts. So I need to think about, are there things I can do to make this material less impactful? So that could mean that I use less of it. It could mean that I'm sourcing from a supplier that's really focused on reducing their emissions, which is going to bring down the carbon footprint of this. So this is all really useful and important data on how we use life cycle thinking to drive our own sustainable product innovation process. So after we run the LCA and we get our EPD, environmental product declaration, or our product carbon footprint generated, we then want to take all this information and continue to use it to decide how we're going to decarbonize our products and operations. So I'm going to launch our first poll right now, if everybody can see this. And the question I have here is, does your new product development process include life cycle and sustainable thinking? So if we could take a look at that poll, that'd be great. And see how things are going here. So if you could start putting your information in there, that'll be really helpful. And I can see that we got people voting. About 56% of you have voted. And the important thing here is when I talk about new product development process, many of you might think of that as a stage gate process or something like that. It might be how you term it. So I see everybody's participating. This is great. Keep going. We're going to give it another 5 seconds. We got about 65%, 66% voted. All right. I think we can stop the poll now. So thank you all for voting. We got about almost 68%. So about 74% of you say yes, you do use life cycle thinking and sustainable thinking in your new product development process. That's great. 26% of you said no. So that means this is something that we want to make sure we understand how we can teach you about this as we go forward. So I appreciate everybody participating in that poll. So let's dive in real quick and take a look at some of the market drivers on why you might be integrating that life cycle thinking and sustainable thinking into your new product development process. So I mentioned last week there were definitely market drivers. Some of these overlap from what we talked about last week. So if we think about it, I talked a lot last week about Art Gensler, their city's climate challenge, one of the biggest architecture firms in the world, and how they're looking at designing more sustainable buildings from both an embodied carbon perspective. Remember, that's the raw materials and the manufacturing of those materials and transportation and whatnot. They're also looking at reducing the operating carbon in the building and then trying to offset whatever's left over after that. And that's being driven by their movement around looking at understanding using life cycle assessment from whole building life cycle assessment to identify what products and materials are driving the biggest impact and giving them the ability then to make some decisions on selecting lower embodied carbon materials and products. So if I go on to the next slide here, if you remember, we talked about this last week as well. The Leadership in Energy and Environmental Design Standard V4.1 is giving us the ability to earn points in doing a LEED building certification by selecting at least 20 permanently installed products that have environmental product declarations. This is a huge driver and why so many of you are doing EPDs. But the other thing is this allows us to earn additional points under option 2 for selecting products that have been optimized, where through LCA optimization, using that lifecycle data and then integrating that thinking into your sustainable product innovation process, it gives you the ability to reduce the carbon footprint of your products and make them more sustainable. That is definitely something that is being driven by the LEED standards. So that's exciting, and we're seeing a lot of movement on that and a lot of activity, which is great. And the way it works is you earn you can earn points by selecting at least 5 permanently installed products sourced from 3 manufacturers that have done optimization, and you qualify that based on the level of optimization. So if you've reduced your impact in global warming potential by 20%, and a 5% reduction in at least 2 other additional impact categories, you can definitely, that will count as 2 products, which means then I don't have to find as many other products to put into my building. The goal of this is to drive more companies to start using life cycle data and thinking about sustainable products. The other big thing driving the need for sustainable product innovation and life cycle thinking is definitely circularity and how it's connected to SPIs in a big way. Just so if we really look at this from studies I've read, right now the world economy is only about 7% circular, which means 93% of everything we make gets disposed of or no longer used, and we do know we're a disposable society. So the great thing about a circular economy is it starts to look at how can we redesign, recycle, reuse, refurbish, maintain something in life, or recover if it's a biological material. This is really driving the need for sustainable product innovation. We talked a little bit about upcoming legislation last week. We are seeing that there's legislation coming out for extended producer responsibility. And what that means is that you, the manufacturer, is going to be responsible for your packaging, perhaps, or even some of your products, which means that I, the purchaser, no longer have to worry about that. And for example, the state of Oregon now has a responsible end mark legislation that's in progress that's going to reduce plastic pollution and improve recycling. And they're looking at driving different groups that are producing packaging to create infrastructure and to make their products more recyclable and recoverable so they can actually not end up in a landfill or end up in a waste energy plant. You can look down here, you can see these are all the states that have extended producer responsibility bills, California and Hawaii. I know if anybody's here from overseas or Europe, you all have, many of your countries do have extended producer responsibility requirements. I know Canada, some of the provinces do as well. So this is driving change. And last week, we also talked about how government agencies are requiring companies that make certain products to create environmental product declarations so they can basically select materials based on the carbon footprint of those materials and looking to reduce that embodied carbon in things like concrete, glass, steel, asphalt, wood, etc. I don't know if you've all seen this report, but this was put out in 2021 by an organization called As You Sow. They are a nonprofit organization that's looking to drive change, and they put out a plastic pollution scorecard. I know that some of the companies that are on this webinar today, you might be on this list, but they basically ranked you as a company in terms of how you're handling your plastic materials and your packaging and whatnot. And you can see here, a lot of companies got C's, D's, and F's in terms of how they were performing based on this scorecard. And some of the recommendations that were made from this were driving greater packaging innovation. So using sustainable product innovation to make packaging more recyclable, compostable, reduced, redesigned, etc. Those are some of the key words you'll see here. And then driving more recycled content into packaging. That's one way to drive the circular economy. Looking at recycled content certification was a big output of this report. So these are all driving sustainable product innovation. And then we see companies like General Motors, and we got this right out of their sustainability report, are publicly committing that they're looking to procure increasingly sustainable materials via carbon emissions reductions through process innovation, recycled material content, renewable and fossil-free energy for electricity, and carbon utilization and storage. And they're identifying plastics, natural rubber, steel, aluminum, EV battery materials, textiles as different things that they're asking their suppliers to start thinking about. So Here's a driver from a direct customer asking you, a supplier, to figure out how you're going to provide a more sustainable material to a company like General Motors. That's a big deal. And these are the things that are really promoting this sustainable product innovation thinking. So now we're going to come up to our next poll. And before we go into this, I want, we're going to have Juliana launch that. So the question is, what defines a sustainable product or material? Is it recycled content? Is it reduced packaging? Is it durable? Is it low maintenance? Is it all of the above? So please start voting and selecting what you think is the correct answer here. And again, there's no incorrect answers. This is just to get your best level of understanding of what a sustainable product really is. So we're going to let the poll run for a few seconds here. Looks like we got about 50-some% voting. This is great. Keep voting. We're seeing a nice cross-section of answers here. Excellent. Keep up the great work. Let's try to get over 70%, and then we'll stop the poll. All right, we got more voting. 68% voted, a little more. Give it a couple more seconds. Awesome. Great work. Thank you all for voting. All right. So if we look at our results, we can see that 87% said all of the above, 17% said recycled content, 16% said reduced packaging, and 11% said durable, 4% said low maintenance. The thing is that you're all correct in some form, but many of you are selecting single attributes, right? So the answer is all of the above, because when we are thinking about sustainable products, we want to take what we call a multi-attribute approach. And it really depends on the product category. And I'm going to state this right now. It's really important when you're designing a product that you focus on your normal things that you do in new product development. You want to make sure you're looking at the quality and the performance of the product, the cost of the product, the durability. These are all really important, keeping it low maintenance. But then we also want to start thinking about lower embodied energy and carbon footprints in the materials we select. We want to think about lower energy use in the use phase. We want to think about, can we design this for end of life, for circularity? Can we select biodegradable or recyclable materials? Can we change the packaging? Is there something we can look at in terms of the chemical components or ingredients in there and determine what those impacts are? Is there any hazards or risks or exposure things we should be thinking about? Anything biodegradable? So again, our approach is to really think about how you can look at this from a multi-attribute perspective. Our sister company creates a label called Certified Environmental Facts and Certified Sustainability Facts. We're going to hear from Michelle Bonanno next week, who's the certification officer for Green Circle, talking about how you as a company, once you do these great things, can communicate this information to people by getting third-party verification. So again, you can see this label here. We'll learn more about that next week. That's definitely talking about multi-attribute aspects and how you would look at this. So when we think about sustainable product innovation, we want to be thinking about the life cycle, right? We're thinking about all aspects of it. We're using sustainability thinking across the life cycle stages and how we can make the product design to be less impactful and reduced impacts. So here's an example of what a stage gate process looks like. I mentioned that term. Stage gate is basically set up where different companies, and they call this all kinds of different things: stage gate, phase gate, new product development process. It has all these different terms, but essentially it's the same thing. You're going to have a stage where you're discovering and trying to understand what the voice of customer is. We have a term called voice of green, which we're going to work on next week when we do our third webinar, all about how to tell the story and market and communicate the great things you're doing in terms of reducing your impacts in your products and operations. And then there's usually a gate where the management team says, all right, before we go any further, we're going to understand what the purpose of this is. We're going to understand what the benefits of moving forward are to take this further into a full development, into a brand new or modified or revised product. So the thing you see here is I have a couple other boxes. A lot of times we want to think about what are things we can integrate here in the stage gate process from a sustainable product thinking mindset. So cost is always a very important one. Looking at optimizing our manufacturing practices, looking at alternative material ingredients, maybe responsible extraction, customer value creation. These are all things we'll think about, and I'll talk more about that in a minute. Now, one thing I want to show you is I mentioned life cycle assessment and the value of it in creating more sustainable products. This is a real life example, just sanitized, where if you look at the blue here, this was used where we created a baseline life cycle assessment, and we were trying to understand the impacts of this product. So once we had our baseline, we presented this information to the company, and then they went back and they said, all right, we're going to take a look at our product and we're going to think about what can we do differently with the product raw materials, and what can we do different in our manufacturing stage that can reduce those impacts. So what happened was they made some changes. They integrated recycled content as one example. They identified different things they could do in their manufacturing plant to reduce energy consumption in terms of fuel use and electricity. They also made some changes in their transportation and whatnot. So what happened then was after they implemented those things or identified them, we rerun the life cycle assessment, and we were able to really reduce those impacts. The green bar is basically showing that how the product was optimized by integrating those things that I just talked about. And you can see here in this case, global warming potential came down about over 33%, down to 67%. And the other impact categories shrunk as well. So this is an exciting graph to me because this shows that we use life cycle assessment to understand those impacts. We made changes in our materials and our manufacturing operations to reduce that embodied carbon and other impacts, and we got great results here. And the important thing to think about is when we're designing products, it's really important to be using life cycle thinking and sustainability thinking early in the process. When we're designing it and piloting it and producing it, going into initial production, we can make some big changes, and we have a very big ability to influence and reduce those environmental impacts. If we wait too long and we don't do those things and we go into products, we're already manufacturing, the product's already in use, it's really hard to reduce those impacts, and it's really almost impossible to influence any changes. And we're going to show you more about that in the Lego exercise in a few minutes. So let's talk about how we can incorporate sustainable product innovation into the new product development process. So the first thing I mentioned, I showed you different examples on that stage gate diagram. We also want to think about usually in stage gate, many companies are doing it in spreadsheet format. So what we typically want to do is in the very beginning, we want to do what we call a sustainable product scores card to baseline the product. I'm going to show you one of them in a minute. But then we also build in like life cycle thinking and manufacturing impact reductions and things like that. So this would be in like gate one. We're going to think about that. And then I'm going to show you an example here of a scorecard. And I will say this is one of our older scorecards. We've evolved this quite a bit over the years now. Like I said, we started doing these scorecards in 2009, working with a hardware and door product company many years ago, back in 2009. And what we do is we look at different categories that are really important to the company in terms of how they want to focus in terms of the product category, like things like cost and looking at reducing raw materials by dematerialization or using alternate materials. If this was something that used water, we would want to figure out how in the use phase we can reduce those water impacts, or if it takes a lot of water to manufacture, what can we do there? We could also look at what we call cradle to gate carbon footprinting. So that's using your life cycle data and the GWP information, global warming potential, which is measured in kilograms of CO2 equivalent to understand. And then we want to think about end of life as well. This is just an example, like I said, and we've evolved this quite a bit. But what it does is then it gives us metrics. We score this. We typically will take a baseline product and say, this is a product we make that is the same or very similar of the new product we're going to do. How do we score right now in terms of cost? How do we score in terms of raw material use, et cetera? And then in the new product, this gives the new product development team some ideas on things they can do to try to maybe reduce raw materials or reduce cost, or focus on using the life cycle data to make some decisions on where to focus, thinking about how we can do recyclability or, extending the life of the product, different things like that to drive circularity. And here's the situation. If you do stuff like this in the beginning, like that diagram I showed you where you can influence change, if you make all the right choices in the beginning, you're going to have lower global warming potential. You're going to have lower virgin material use designed for a circular economy. If you don't use that type of thinking, then you're going to have higher GWP, higher virgin material use. Your products will probably end up being disposed of in a landfill. So these are just different things that we would think about. So I will say that there is some companies that we've done this with. We've done this with actually probably close to 50 companies now, helping them build this kind of thinking into their whole new product development process. And I can show you this information because it's publicly available in the Assa Abloy Sustainability Report. You can see all the way back in 2016, this company was using a sustainable product scorecard type of methodology they call their sustainability compass to drive change in their new product development process. So that's really exciting, and we've proven that it works. The other thing that we can see here is that oftentimes there's a whole team that works on this. Like when you're doing new product development, it's usually not just the R&D department. It's usually going to be a product manager, a program manager. You're going to have usually a senior executive that's kind of guiding the process. And then you're going to bring in people from marketing. The marketing team is really important because they're listening for voice of customer. And like I said, next week, we're going to do an exercise on listening and trying to decipher voice of green. You definitely have situations where you're bringing in engineering and your supply chain team, logistics. Everybody's involved in the new product development process. So really important that you're getting everybody spun up and using these thoughts as they go forward. So remember last week, for those of you that were on the webinar, we did an exercise called the tire exercise, where we were really thinking about what is a tire made of? How do we understand those life cycle impacts using life cycle thinking? And we presented this slide where we were saying for a tire, we want to ask questions in our new product development type process after we do our LCA is, which of these ingredients might be hazardous? What alternate chemicals could be used? Maybe something less toxic, bio-based, rapidly renewable, or any of the chemicals produced as a waste or byproduct from another facility. Is there any risk or future supply chain limitations that could really affect our business? Can the materials be recycled? These are all things you should be thinking about in a new sustainable product innovation process. And the thing I didn't show last week is there are real tire examples where companies like Goodyear, DuPont, Bridgestone, Ford are all looking at how they can make tires more sustainable. Trying to go with bio-based materials, DuPont and Goodyear. These might be a little older, so there's probably even more data on this. Bridgestone looking at using a certain shrub to create a viable source of rubber instead of just rubber trees. Ford was using discarded tires to basically take materials and embed it in their vehicles instead of putting in a landfill. So these are all things that are exciting to say that if you start asking the right questions, we're actually seeing real large companies in the world taking a deep dive on this to try to solve some of these problems as well, which is exciting. All right, so we're around perfect timing now. It's 11:32. I'm going to want to take a dive now into this Lego exercise. So this is where we're going to get very interactive, folks, and we're going to ask you to start answering some polls. But let me set the stage here. Like I said, normally if we weren't on a webinar, we'd be in a room, we get to play with and touch the Legos. But this is something that we all love to do. Probably many of you have kids or grandchildren that have played with Legos, or maybe you played with Legos when you were young. Really a fun thing to do. So what I want you to do is we're going to take a look at this product today, a pen, and we're going to think about how can we design this pen? How can we build a more sustainable pen using life cycle thinking and thinking about the materials that are used? And that's only one element in our multi-attribute approach, but we want to think about, if I'm going to select materials, what materials would I select that can make this pen more sustainable? So what we're going to do is I'm going to show you a series of different material choices. You're going to have the ability to select what type of plastic would you want to use to build this pen. You're going to get to check, select the metal. You can see we got metal in this. And then you're also going to get a chance to decide what kind of packaging you might use from a material perspective. So what I want you to do is any thoughts you have, you can put in the question box, but you can actually put them in answer the poll that we're going to launch in a minute here. And I want you to be considering the materials used, sourcing location, waste created, packaging, all that kind of thing. So I'm going to give you, a minute or two on each of these polls to make your answer. So the first thing we're going to start out with is, this is your bill of materials. I've got a pen. We're all used to using these. You can see the different materials here, the plastics, the metals, And then this came in a package. So I want you to decide, I'm going to select plastics now. I have 3 choices. I can pick polycarbonate, acrylonitrile butadiene styrene, which is ABS, or polypropylene. These are the different ways you would get them made. I can choose metals. I could choose aluminum, stainless steel, or steel. I could choose cardboard for my packaging in virgin cardboard or recycled content, or PVC plastic to package it in. So we're going to start out with plastics, and I'm going to roll here. So I'm going to give you a minute if we can launch that poll. I want you to think about, what do you think is the most sustainable plastic from a embodied carbon perspective that we could pick to, and what color Lego would be associated with that? If you were assembling the Legos here, you'd be picking the Legos. And remember, polycarbonate, that's a number 7 plastic. ABS is a number 7. Polypropylene is a number 5. So if you were going to pick one, what color Lego would you assign here? What would be your choice? And again, we only have our embodied carbon or carbon footprint hats on here. So what would we be thinking about? So we got a lot of people answering. I'm giving you a few minutes here. I see we've got about 61% voted. I'm going to try to get up to 75% voted on this to give you all time to really participate. Awesome work. Thank you. Keep it going. We're at 68% voted. We're going to give it probably another 30 seconds. Give you a chance, because I'm sure some of you are thinking, maybe some are Googling this on your phones or your computers, trying to figure out what's the best answer. If we were in the classroom, you couldn't do that, because I would say no phone use allowed. All right, we're almost there. Give it another 72%. Let's go a little longer. All right. Couple more seconds. All right, beautiful. All right, so about 13% of you, or 15% voted for polycarbonate, 9% voted for ABS, 77% voted for polypropylene. Correct answer is polypropylene. And again, we're only looking at this from an embodied carbon perspective. So if I click one more, when we look at the embodied carbon, what we looked at is cradle to gate on these various plastics. Again, we're only looking at this. This is not a perfect exercise, but just gives you a good indication. But if I looked at the different plastics here, the polycarbonate, the polypropylene, the ABS, I would be looking at, from a raw materials extraction, transportation, and manufacturing of these, typically to get this plastic. This is on average, and this comes from our LCA databases. This is on average what we would see per kilogram of product. So the embodied carbon per kilogram of polycarbonate in CO2 equivalents would be about roughly 7.5 or 7.8 kilograms of CO2 equivalent per kilogram of polycarbonate plastic. Again, the pen doesn't have a full kilogram in it, but it gives us a relative area to look at. And I can see here that polycarbonate is much lower than the ABS and the polycarbonate. So remember, low embodied carbon is better. So we want to pick the lower impact here. Again, not perfect, because we have to use full multi-attribute thinking here, because you'd have to also consider costs and other things when you make this selection. But this gives you an idea on what is a good choice there. All right, let's move on to metals now. So now we're going to look at what is the most sustainable metal for the pen. We have choices are aluminum, stainless steel, and steel. What are your choices here? Let's open the poll. We can pick different things here. Looks like everybody's voting, doing great. Same kind of concept here. What would be the best metal I'm going to use in this pen? Awesome. We got about 50-some% voted already. This is great, going well. Everybody's really driving forward here. Again, we got our embodied carbon hat on. What are we thinking? What color Lego would I pick? And ideally, what you would do is assemble all the Legos and try to see where you are. All right, we're doing great. We're up to almost 75%. We're going to go a little longer. We'll go to even another 10, 15 seconds here. All right, numbers or votes are coming in. Beautiful, beautiful work. Thank you all. All right, we got about 74. Give it another second or two, see if we can get to that magic 75%. Let's go. All right, I think we can close that poll. We got it, 75%. So 67% of you said aluminum, 14% said stainless steel, 20% said steel. That's awesome. Correct answer is, from an embodied carbon perspective, it would actually be steel. That would have been your green Lego you would have picked. And if we go to the chart again, we look at the embodied energy or embodied carbon of these metals. Again, same thing. Aluminum is up around a little over 20, maybe 21 kilograms of CO2 equivalent per kilogram. Again, the pen does not have a kilogram in there, but it gives us a relative magnitude. And one thing I did is I also ran, what does it look like if I go with recycled aluminum instead of virgin aluminum? Look at the reduction by using recycled aluminum. And the reason that is you don't have to extract the aluminum, the bauxite from the earth. You don't have to do all the very energy intensive processes of melting down rock to create aluminum. And when we're recycling aluminum, there's a lot less energy, there's a lot less inputs. So the recycled aluminum comes down. So we could also look at stainless steel or steel recycled contents as well. But if we are only looking at the pure metals, steel wins with the lowest embodied carbon compared to the other metals that we chose here. So again, great work. About 20% of you picked steel, so excellent work there. All right, now our last thing is we got to think about the packaging. What is the most sustainable packaging for the pen? Again, we can have a cardboard box with virgin cardboard. We can have a cardboard box with recycled content. We could go with PVC plastic. Again, we're using our thoughts here in terms of what's the best. So thinking about all these things, the poll is open. We got about 47, 80, 50, 53% of you voted. Keep it going, keep it going. Looks like the recycled content box is in the lead. Again, you never know that you think intuitively, you think things, but you never know what's going to happen. So when we're looking at embodied carbon, you never know. So keep it going. We're going to try to get about 75% of you voting. Great work, great work. We're coming up on 70%, a couple more votes. Any more thoughts? All right, 70% of you voted. A couple more seconds here. All right, doing really well. Looks like the cardboard box recycled content is winning by far. All right, we got 75%. We can close that poll. Great work, everyone. So if the correct answer from the embodied carbon perspective is actually the recycled content cardboard box, I gave you a little hint on that based on the aluminum that we just looked at. Again, lower embodied carbon is better. Here we're looking at a full kilogram of cardboard. And one thing that I do have to point out, though, is based on our LCA databases, this cardboard, depending on how it was manufactured, if the actual paper mill that was making virgin cardboard might have been using renewable electricity or burning or using biomass fuel, then the impact could be lower. And sometimes if the recycled cardboard was done in a plant that's using electricity that's coming from a coal-fired plant, then the recycled cardboard could be a little higher. So that's why you use LCA, to understand that, and why it's important to look at geography and locations and use actual grid mix and all that kind of thing. So really important. And you can see the plastic is much higher than the cardboard would be. So, but we also have to think about end of life. How will we manage these materials and things like that? So again, the most sustainable pen, if we were going to build it purely based on the exercise here, we would have a yellow Lego, a green Lego, and a red Lego. I never make the Legos. Intuitively, people all try to pick the green ones, but we never do the exercise that way. So this is the way this exercise would work. And if you did select aluminum with recycled content, that would have been, if that was a choice, that would have been actually the better choice for the metal. However, we got to think about this as well from the perspective of performance and quality. If I went with aluminum versus steel, would the pen last as long? If I went with polypropylene, is the plastic going to perform as well as ABS? So you can't just use the embodied carbon only as your decision tree. You got to use it as one element in your overall decision process. And it's a multi-attribute approach to sustainability of products and materials. It's a multi-attribute approach when you're thinking about your sustainable product innovation and what you're doing there. So like I said, what makes a better product? You got to make the right choices early on. And we do know that lower is better in many cases. So again, selecting those right Legos is really important. And one last thing, like I said, if we look here and we start running other choices with the metals, remember global warming potential, that's what's driving greenhouse gases. We're measuring those greenhouse gases. The embodied carbon is all the CO2 equivalents of that. And then when we start looking at the raw materials and we start looking at the manufacturing, all of that's captured in here. So aluminum, virgin aluminum by far is the highest impact. However, when we start really going to recycled, that becomes very low. But look at recycled steel also. So suddenly I got another choice I can make. Maybe the recycled steel is a better choice. So again, factor that in when you're making decisions. All right, I'm going to go through a few more slides and then we're going to roll into questions. So we talked a lot about materials with the exercise and using sustainable product innovation, but it's really critical to start thinking about decarbonizing your operations. So remember in that first slide I showed, the manufacturing stage made up about 15% of the overall embodied carbon in that product. And this is where many of you that are making big commitments around science-based targets or other things have to start thinking, what can I do to reduce my scope 1, my scope 2 emissions? And that comes from what we call doing a sustainable operations assessment. And we know operations have a big effect on your economic, environmental, and social performance as an organization. It directly affects your embodied carbon of your products. It definitely has a connection to energy use, water consumption, raw materials and waste, and the overall carbon footprint of your operation. And I can tell you that if you can establish sustainable operations, I guarantee that you can save money, and I guarantee you're going to reduce your emissions. I guarantee you're going to reduce the amount of energy and water and materials you use. We've done hundreds of these sustainable operations assessments where we come in and we look at opportunities. And having done this for probably my whole career, this is one awesome way of driving down your impact and driving right to the bottom line. A couple of companies, we give a couple case studies here. We did this for a large pharmaceutical company. We identified $2.5 million in savings. We did it for another building product manufacturer and almost $2 million in savings that they could realize from doing sustainable operations. And what I would recommend all of you think about, especially if you have science-based targets or big goals, you want to think about creating what we call a decarbonization master plan. And that's where you are basically taking a sustainable operations assessment and using a concept we call energy efficient design to really dive deep into alternative technologies and everything else to help meet net zero goals and science-based targets. And by doing this, it's directly going to reduce the embodied carbon in your products by reducing those manufacturing stage impacts. So very important to think about that as you go forward. And I will say that if you are thinking about this, the big challenge I'm going to say to all of you is scope 1 emissions. If you're in an energy intensive industry that uses a lot of fuels and natural gas, it's very hard to make those changes, especially if you're a steel mill or you're, a high impact sector like a chemical plant. And it's really important to start thinking about alternative technologies. So when we do this, when you're thinking about decarbonization, you want to be thinking about your emissions today, your emissions, how they grow in your operation. And then our philosophy is we want to look at what we can do to change operations and behavior. We want to make building and equipment upgrades. We want to look at thermal solutions, electrification, and alternative technologies before we even think about green, renewable electricity, carbon-free electricity, or carbon offsets. So really important to save as much energy as possible before you go forward. And I will say that there's a lot of movement now towards renewables, especially for electricity. And the best source you can ever do in terms of looking at this is on-site. You really get the electrons going right into your plant. You can do a thing called a power purchase agreement where you're having someone install solar panels or other renewables on your property or on your building. Those electrons come into your building, but it's important then that you own what's called the renewable energy credits. A lot of companies are doing what we call virtual power purchase agreements where they're paying big dollars and investing in long-term contracts to build large solar farms or large solar fields, or you can get green power right directly from your utility. And there's also what we call renewable natural gas, which comes from landfills and anaerobic digesters and farms. But it's important to note that we still get burned, so there's still CO2 emissions when you burn that, but it's way better than releasing that methane to the atmosphere. So important note since we're talking about life cycle assessment and sustainable product innovation, there are very specific rules when accounting for renewable electricity, especially for RECs and VPPAs. So when you're doing a life cycle assessment or a product carbon footprint, you really have to look at those and have transparent disclosure of how those renewables are being accounted for in your LCA or product carbon footprint. So keep that in mind. So if you remember last week, we did the tire exercise. We talked about manufacturing considerations. How can I make a process more efficient? Is there waste heat I can recover? Can I reduce scrap rate, et cetera? These are all good questions when you're trying to look at your manufacturing operations. And we do have a great download on Conquering Carbon, which I know our team has sent out to all of you that are participating and signed up for this webinar series. So driving continuous improvement, what I'll say is, how can companies reduce embodied carbon? Definitely use life cycle assessments, use sustainable product innovation, do sustainable operations assessments to drive that continuous improvement, and really think about what you can do to drive reductions by sourcing raw materials from a closer location, reducing material used in your products, reducing packaging, creating take-back programs using renewable energy or electricity. And we do have a download specifically on reducing embodied carbon in your products. So take advantage of that. We will have a homework next week, just like we did. And I want you to think about your company's new product development process, the stage gate process, and determine what stages where you would integrate sustainable product innovation. For those of you that are already doing it, I think you can do this homework and say, where are we doing it now? Is there somewhere else we should be doing it differently? For those that have never done it, you can use what you learned today and use that in your thinking. As always, we do have a great wealth of resources that are available, podcasts and everything else that are going to help reinforce all this. We have a survey that'll pop up right after we end this webinar. Please fill it out. It really helped us last week in the way we structured this week's webinar, and it'll help us for the third webinar next week. So if you can get that in, that'd be great. So our next webinar is next week, September 20th, how to communicate, market, and certify your LCA and PCF results. So with that, I'm going to have questions. We have time for that right now, about 8 or 10 minutes. And I do want to remind you all, if you have any specific questions, you can definitely reach out to Nicole. She's one of our LCA experts. We have LCA experts in our team. We have sustainable operations experts that are ready to answer your questions. So feel free to reach out to Nicole at any time. Her information's here in the slide deck. So with that, let's start with questions, and I'm going to take a look at some of these. Appreciate everybody that's been putting in your questions. So I'm going to start at the top right here. How can companies make decisions on PCFs while not every player in industry provides PCFs? Would it narrow down to who offers PCFs and who doesn't? And can you profit on that offering and how? So I think what I'm understanding from that question is, right now I will tell you that the product carbon footprint market is very early. It's growing. There are more and more companies starting to create product carbon footprints. There's a lot more companies starting to do life cycle assessment and to do EPDs. I think the important thing you should do is ask these companies to start doing it. I showed an example last week in the webinar where we have Together for Sustainability, which is the chemical industry, all came together and they're asking suppliers in the chemical value chain to start doing product carbon footprints. Some of the bigger companies are requiring it of their suppliers. So it is important to get it done. But the ultimate goal, if you remember last week, we talked about the value of primary data. So usually when we're doing a product carbon footprint, if we don't have that primary data, we're going to be using databases that aren't perfect, and there's uncertainty in those. The more we can drive to primary data, the value comes from, it gives you the ability to actually get real data that you know is more accurate and higher quality. It also gives you the ability then to work with your suppliers to see where their impacts are and to possibly help them to start thinking about how they can reduce their carbon footprint, which is going to hopefully save them money. It's also going to also reduce their carbon footprint as a company, which is going to benefit them. So I do know that some companies are saying, I saw this recently, they are saying if you don't have a product carbon footprint and you're a tier 1 supplier, by X date, we're no longer going to source from you. So that is something that is happening out there. So next question I have here is, any organization creating a point system for products that are designed for easy disassembly? For example, materials can be efficiently recovered. For example, like lead credits are awarded for building materials. I have not seen that system yet, but I do know that there are product passports and things being developed. This is something that we are looking at as a company in the sustainable product innovation process, and we are working with several industry associations on this right now to examine that. But I think that would be a great tool to have something like that, where if there was a tool, you can definitely start to make decisions. The more we can use scorecards and tools, the better. And I do know that many of the platforms that are out there help companies measure the circularity of their products, but those tools aren't even perfect yet. I know the World Council on Sustainable Development has a tool, and some others, but again, not perfect, but something that works. So next question, based on our experience, what are the top LCA tools currently available on the market? I mentioned this last week. We are using, as a company, we're using CimaPro and Gabby. They're both fine softwares. We do like the fact that with CimaPro, we can actually really have a lot more transparency in the data sets we use. Gabby has a lot of good benefits as well, but they're the ones that we typically use. And the reason we like to use those is they're fully supported with updates to databases, new technology, and things like that. So that's what our company focuses on. Another question that we had, somebody asked, should densities be compared as well? That's an excellent question. Absolutely, densities are important. And what that means is we have to look at what is the overall amount of materials in a product, what is the product density, and things like that. So we do definitely focus on that. For the simple exercises we're doing today, I didn't go into that, but that was a good question, and we would absolutely look at that. There's a question about recycled products. Does the carbon associated with recycling, is that included in the embodied carbon? Absolutely. When you reprocess those materials, that is captured in there, because many of the materials do require reprocessing. There's going to be a collection phase, and then there's going to be a phase where in many cases you have to process them and work on inputting energy and impact in terms of getting that material into a state that it can be reused. So that does get captured for sure. And it says, is mining processing not included? That's correct. So the mining and the processing from a recycled metal, because we don't have to do that stage, it was already done once, we don't have to account for that again. There was another question here. We do not manufacture anything on site. We just design and assemble the final product. Sometimes there are multiple suppliers between us and the initial supplier. And it says, how would you suggest lowering the footprint of the materials we purchase without the actual data? So what I would say here, just like we talked about today, this is where focusing on your scope 3, that's what that is, understanding who your suppliers are. We have a lot of companies we work with that are assembling things, and they don't really make any of the raw materials or ingredients or components. So what I would suggest is driving that down to your suppliers in the form of having maybe a supplier forum, letting them know this is important to you, showing them that at least based on the life cycle assessment you did, you identified that some of the raw materials or ingredients or components they're providing to you are big drivers, like that slide I showed showing material 7, material 1, and material 2. And then I'm a big fan of collaboration and sustainability, getting those folks to work together, and then eventually trying to get them to give you the actual data. And we as a company are doing a lot with scope 3, where we're working with suppliers to help them measure their scope 1 and scope 2 emissions and to figure out ways they can reduce them. We are doing some work with some industry associations across the value chain to drive that thinking from the beginning raw materials all the way through So that's how you would do that, get that collaboration, communication going. And then eventually you can require them to do that, give you that information. And that's what we're seeing. That's why suppliers in the chemical industry are saying, hey, if you're in the chemical value chain, we want you to do a product carbon footprint. You can drive it the same way. There's another question here. What is the difference between recycled metals and green metals? So recycled metals would be metals that are recovered, and basically recycled back into themselves. Green metals are typically going to be made using lower impact energy methods. So there's a big movement on that with specifically aluminum and steel now on, if you look at like steel mills, many of them are driven by electric arc furnaces. So if you could source all your electricity, say from either a nuclear power plant or a utility that has all hydropower, then you would actually have lower carbon footprint on making that steel than if you were buying electricity off the grid or from a coal-fired plant. So that's what the difference is between a green aluminum or a recycled aluminum. They both could still have recycled metals in them, but you're lowering that reprocessing phase of that. Same thing goes for the actual virgin aluminum smelter. If they're doing different things there, they can use renewable or carbon-free electricity. All right, I know we're at 12:01, so I'm going to wrap it up here. Look forward to seeing you all next week, and thank you all for participating in all your interaction. Really appreciate it, and look for emails from our team.